This video is designed for students that have already taken linear algebra or just want a quick look at what determinants are so that we can use them in our differential equations course. So the question for this video is, how do we find basic determinants? And determinants tell us a lot of things about matrices. We're just going to focus our discussion on how to calculate them, and you can look at how to use them in other videos. Determinants are always squares, so we're going to start with the case of a 2 by 2 determinant. And by definition, we'll have a 2 by 2 determinant, which means there's 2 rows and 2 columns of things. And then to calculate that 2 by 2 determinant, we'll take the downhill diagonal, which is AD, and we will subtract the uphill diagonal, which is BC. So for example, if I've got a determinant with the numbers 3, 5, -2, and -4, we'll multiply the downhill diagonal 3 times -4 to get -12. And then we'll subtract the product of the other diagonal. 5 times -2 is -10. And then we can calculate that to be -2. So 2 by 2 determinants are pretty straightforward. We can extend that theory onto a 3 by 3 determinant. By definition, a 3 by 3 determinant is defined in terms of smaller determinants. We've got 3 rows and 3 columns now. So we'll say A, B, C, D, E, F, G, H, I. And the way we calculate a 3 by 3 determinant by definition is we're going to work across the first row, starting with A, although you can really do any row or even any column. And then A, if we cross off the row and column that A is in, it leaves behind E, F, H, I. And so we'll do A times the E, F, H, I determinant. Then we'll look at the B, which means we'll eliminate the B row and the B column, and we're going to subtract B times the determinant of everything else that's not in that row and column, which would be D, F, G, I. Then what we'll do is we'll add, and then we'll take a look at C, crossing off everything in C's rows and column, which leaves behind our 2 by 2 determinant of D, E, G, H. And so this is kind of how we, by definition, calculate a 3 by 3 determinant. And if it's a bigger determinant, we can actually extend this theory on towards larger and larger determinants. But 3 by 3 determinants specifically have a nice little shortcut that we're going to use to our advantage. So we're going to do the same A, B, C, D, E, F, G, H, I 3 by 3 determinant. And here's how the shortcut works. We're going to repeat the first and second columns next to it. A, B, D, E, G, H. Then we're going to take all the downhill products. There should be 3 of them. A, E, I, B, F, G, add it, and C, D, H. Then the other direction, the uphills, we're going to subtract. Putting it in order, it would be C, E, G minus A, F, H, and finally B, D, I. And that then will calculate the determinant of our 3 by 3 matrix. We're going to use that shortcut more than the definition just because of how slick and quick it is. So if I wanted to calculate the determinant of 7, -2, 1, 3, -4, 5, 6, 8, negative 9, we would follow this pattern. First, repeat the first and second columns. 7, negative 2, 3, negative 4, 6, and 8. Then start looking at the downhill products. The first product is 7 times negative 4 times negative 9, which is 252. Negative 2 times 5 times 6 is negative 60. 8 times 3 times 1 is 24. And now we subtract the downhill products. 1 times negative 4 times 6, we're going to subtract a negative 24. 7 times 8 times 5, 40 times 7 is negative, or is 280, so we're going to subtract 280. And finally, we'll subtract the last downhill product. 9 times 3 times 2 is 54. And when we combine all of those together, we'll get our determinant of our 3 by 3 matrix to be negative 94. Hopefully this video was a nice little review of how to calculate 2 by 2 and 3 by 3 determinants, and hopefully it'll be useful to you as you work on your differential equations course.